take this I went in with like 200 topics done.
Nice.
It was like,
All right, let's get started in actual calculus now. I found out yesterday they're getting rid of my program that I used to do all my whiteboards, so I'm trying to find a new one. We're going to try this one, see how well this one works. I love Google canceling things and getting rid of stuff that we actually use. It's like, why? All right, so find me the derivative of b to the y equals x. Yes.
Would you start by using ln to move the y to the beginning?
So if we move the ln over, do you know what the derivative of ln of x is?
Yeah.
Huh? Yeah. So when we did, and I said, look back at your notes from 3.1, because in section 3.1, we figured out what the derivative of e to the x was. And if you remember, we found out that it was actually e to the x. But before we did that, and before we showed that, I showed you what the derivative of b to the x was.
B to the x.
Almost.
B.
I was going to say, just find it. It's there. Yes. It's 3.1. It's the very first section of chapter 3. It was right after we did the power rule and stuff. So e to the x is e to the x. B to the x is b to the x ln of b. And what's ln of e? What's ln of e? Yeah, 1. That's why it doesn't have it, because ln of e is 1. So I don't have to write that here because that's just 1. So that's why e to the x. So let's look at this. So I have b to the y equals x. So if I want to take the derivative of both sides, the derivative of this side is b to the, b to the y, ln of b times the derivative of y, so dy dx. Because I still have to do my chain rule. This is what we did last class with the implicit differentiation. What's the derivative of x?
1.
1. Now let's solve that. Let's solve that for y, or for dy dx. So I'm going to move the by and the ln of b over to the other side. So dy dx equals 1 over ln of b.
Why you keep the dy over oh. Because it's y.
Yeah, that's the derivative of y. So it's y prime. What was b to the y? B to the y equals what? X. So that means this is 1 over x ln of b. True? All right, so what we found was the derivative of
Why do y dx so there? Why?
because it's the chain rule. You have to take the derivative of y.
Now we see why.
Right. So, the other way we looked at it the other day was we did y prime. Y prime and dy dx are the exact same thing. It's both the derivative of y. So because y is a function, it's not just a variable like x. We have to have the derivative of that left over. That's where we were looking at the implicit differentiation. That's why at the end of all those problems, we ended up solving for the dy dx and getting the other stuff by itself. So yeah, dy dx is the same as y prime. That's there. 10. There we go. Those are the same thing. All right. So what's the derivative of this? How can I rewrite this? Yeah. Yeah. Those are the same thing. Okay. So we just found the derivative of this. So y prime is 1 over x ln of b.
Would you run log?
Yes. Is log and ln the exact same thing? Kind of. What's the natural log? NL is natural, or ln is natural log. It's a log of base e. So you could put the log, but you'd have to put log base e.
So you get the log e.
Yeah, which is just ln. That's why we use ln. Yeah. Yeah. We did something, we used something we already knew to now show something that we're going to need to use. So, because up until this point, we have not been able to find derivatives of logs. We've been able to do derivatives of some exponents. We've done e to the x and stuff like that before. I really haven't done much of with like 2 to the x and 3 to the x and stuff, but we can. But we haven't done anything with logs, and we need to have an ability to do logs, especially the natural log. So if I said y is ln of x, what's the derivative of that? Now b is what? B is e. So what's ln of e? ln of e is 1. That's okay. I know, lots of little things. So the derivative of this is just 1 over x. This one comes up a ton. Okay? The derivative of ln of x is 1 over x. And it is also going to be probably one of the most important integrals that you're going to learn. That the integral of 1 over x is ln of x. Okay? Yeah.
If you have a log ln, are you automatically going to switch 1 for something for every fraction?
Yeah. All right. So we have our derivative of regular log. The only difference is it's log ln of whatever the base happens to be. But the derivative of a natural log is just 1 over x. Okay, and that one's going to show up a lot. All right. Let's use it. Let's see if I can. Let's see. Nope, it's not going to let me do that way. That's fine. All right, so let's look at this one. How would you want to go about doing it? No, we don't want to rewrite them anymore. You could, but then you're going to have to do implicit differentiation. You're right back to where we are anyway. But we now know how to find the derivative of the natural log, so I don't need to do that stuff. However, we have this inside of it, right? We have that inside. So what rule do I have to use when I have a function inside of a function? I have to do the chain rule. So what's the derivative of x squared, x to the third plus 1? Right, 3x squared. What's the derivative of ln of x? 1 over x. Okay, so my derivative of this is 3x squared, because that's the derivative of the inside, correct? Times 1 over, is it over x, or is it over x to the third plus 1? Remember, when you're doing the derivative, you put what's inside left over, so it's x to the third plus 1. That's my derivative. Remember, the derivative is always the derivative of the inside times the derivative of the function on the outside if the derivative with the inside, if the inside was just one thing. But you still have to put that there.
You don't have to keep the in there anymore.
No, because the derivative of ln of x is 1 over x. So remember, it's if m was x to the third plus 1, m prime is 3x squared. So my derivative is m prime times 1 over m, which is that. Because it's the derivative of the ln as it is just that function.
Excuse me, Professor.
Yes.
Differentiate just means find the derivative.
Yes.
Thank you.
No problem. All right, take a second and try to find this, or take a minute or two. Okay, that doesn't work. Yes. Sure. You're welcome. That's not what I wanted. How it's working, and more interested in the other piece. That's right. Which is what? That's right. That's the cosine of x. So that's going to that. This is 1 over what's the line. Yeah. So the sine of x. That's how they get cosine.
Question, Professor.
Yeah.
Where do I go from here? So I have the G's and the F's.
Okay, so your derivative of the inside is cosine,
Okay. Is that, well,
because the derivative of sine is cosine,
okay.
and then it's times what's the derivative of ln of n, or ln of
1 over X.
right. But what's the x value going to be? What's inside the ln right now?
Sine of X?
Right.
So it's just 1 over sine of X?
Yeah, that's the next picture.
Sine of X equal.
Yes.
Or professor, or just cotangent, right?
Yes. All right. So what's the derivative of the inside? Right. So sine of x goes to cosine of x. So my d dx equals cosine of x times what's the derivative of ln of sine of x is 1 over sine of x, which equals cosine of x over sine of x, which is cotangent of x. Okay. So you have to remember, and this is, if you remember right from last Wednesday, when we did the chain rule, I said practice the chain rule because the chain rule comes up almost everywhere from this point forward. All right. You're going to have a ton of functions inside of functions, especially when you're dealing with like ln's and trig functions, stuff like that. You're going to have things inside of them. So that chain rule is very, very important to make sure you understand. So I did put a WebAssign up there with the extra practice for just the chain rule lesson because I think that's where you're going to need most of your work. Plus, it'll cover everything else you've done before that point too. So practice that section because it's going to build from everything after that point. All right, let's look at this one. I don't like the way that it not does a lot. That's okay. I'll figure it out. All right. What's the difference in this one? It's log base 10 instead of ln. It is just log, but it's not ln. Because my base is 10, not e. There's a reason they put that there, though, because remember what we did back here. The derivative of log base b is 1 over x ln of b, not just 1 over x. So since my base is 10, I need to have the ln of 10 in my problem. Okay. Yeah. So what's the derivative of 2 sine x? That's just cosine of x, right? Because the 2 disappears. So I have cosine of x times, what's the derivative of log base 10? 1 over 2 plus sine of x ln of 10. So it's going to be the same thing. It's still 1 over whatever it was, just like we did the ln's. You just have to have the ln of whatever the base is there. In the ln ones, when we did it, we didn't have to have that because it would be ln of e, which is 1. Every other case, if we have just a log, we need to put that there. I will tell you the vast majority of problems you're going to see going forward will be ln's and not logs. Okay, so this is nice to know because it can come up every so often, but it is not something that comes up very often. Okay, most of your problems is based on ln.
Do you have to change LN for this one?
What, the ln of 10?
Yeah.
You always are going to have that. It's always going to be ln of 10, or it's always going to be ln of whatever the base is. So if I did log 2, so if I took the exact same problem but I changed it to log 2 of 2 plus sine x,
Log always goes in.
right, this would be basically the exact same thing. It's going to be cosine of x over 2 plus sine of x, but it'll be ln of 2 instead of 10. Okay, that gives you that. That's the piece you need to have there. And it's the same thing when you're doing the derivative of any of the exponents. So the derivative of, for example, if I wanted to find if y was 2 to the x, y prime of that is 2 to the x ln of 2. You always have to have that ln because the base is not e. Okay. Want to try one more of those? Let's get you another one of those before I move on to the next piece. Let's do this one.
They got the answer.
Good. I'll go in a second. All right, what's the derivative of the inside?
Secant.
What's the derivative of the log base 8? 1 over. So you can put it all together. The ln can be in the front or at the end. It doesn't make a difference. The one thing I will say, if you're going to put it in front, just make sure to put parentheses around it. Just because sometimes it makes it a little iffy. It's like what is part of the natural log and what's not. So that's why I typically put the natural log at the end. Same thing with like square roots and stuff like that, because you're not sure where quite it ends. So, but that's my final answer. All right. Let's take a step back for a second. I'll erase or the absolute value sign. We don't really need those things. All right. Who remembers how to break up natural or logarithms? Right. So division becomes subtraction. Multiplication becomes addition. All right. So let's take this one step at a time. So this can become ln of 3x plus 4 to the third minus ln of x square root of x plus 5. You should have learned it in algebra. I doubt your pre-calc teacher probably reiterated it because I know I didn't. That's one of those. It's the exponent and log rules that you should have remembered from like college algebra in those classes. And since I'm going to assume the vast majority of you don't, that's why I'm going over it. All right. So remember, division becomes subtraction, addition becomes multiplication. So, or multiplication becomes addition. So we have now a multiplication step here, right? So we want to split that up. So I have ln of 3x plus 4, the third, minus ln of x plus ln of the square root of x plus 5. All right. How do I move exponents out?
Make them the coefficient.
Yes. Exponents become coefficients. So if I had ln of x to the third, that's the same thing as saying ln of x times x times x, right? Yes? Which, based on the rules we just said about multiplication, becomes ln of x plus ln of x plus ln of x, right? Which is 3 ln of x. So that just comes down in front. Saves me all those extra steps. So that 3 is going to come down in front. So that's 3 ln of 3x plus 4 minus ln of x. What's the square root exponent? Right, so minus 1/2 ln of x plus 5.
Isn't that plus?
Nope. Yes. Distributed the negative. That's why they're in brackets to begin in that step before it. Because if you didn't, you would mess up your sign.
Would you still be able to do it? Let's say you put ln over x plus 5 squared. Change x plus 5 to the 1/2, like take it.
Well, x plus 5 would be the 1/2 power. It's not 1 over x plus 5. Because that'd be negative 1. Yeah. All right. What's the derivative of this? Like, wait, you want me to do more math? The nice thing about derivatives is if addition and subtraction, we can split them up and look at them individually, right? I don't have to look at this as one whole problem now. I can look at this as 3 problems. So what's the derivative of the first one? So I have 3 times, what's the derivative of 3x plus 4? 3 over 3x plus 4. Minus, what's the derivative of ln of x? That one's easy. It's 1 over x. Minus 1/2. What's the derivative of x plus 5? One over plus 5. Yes. Distributed it. Actually, I'll leave the arrows there.
I got lost on the first one you did.
So that 3 is that 3.
Yeah.
The derivative of that is 1.
Okay. All right. Thank you.
You're welcome. So if we clean this up a little bit, I have 9 over 3x plus 4 minus 1 over x minus 1 over 2x plus 5. And that's the derivative. Can I? Yes. Am I going to? No. You just found the derivative of this. If you didn't split it up, I'll scroll back down to 1 second. If you didn't split it up, you would have had to do the chain rule and the quotient rule on the thing inside here. Okay? So by using the rules for a logarithm to split this up, it made it a lot easier for me to do that derivative. Okay? Because the derivative of ln is actually really simple to do. It's just 1 over whatever's inside of it. Times the derivative of what's inside of it. So that's where it's 1 over 3x plus 4 times 3.
Why is it 3? 50.
No, because it's the derivative of the inside is the 3. That's multiplied by it. And then it's 1 over whatever is inside. Not 1 over whatever is in the derivative of what's inside. It's 1 over whatever is inside. That's where the 3x plus 4 is.
Why'd you move the 2 down? 'Cause
1/2. It's 1/2. So just put that on. So knowing how to do the derivative of a natural log. Now, if we had done this, the original problem, which would have, believe it or not, taken a lot more steps than what we just did, you'd have ended up with one fraction at the end. We could take those fractions and put them together if we wanted to. We are not going to because we don't need to. All right, that goes back to the whole concept of where do we end for simplification. I don't need to do anything else with this one, so putting it together in one fraction isn't going to help me anymore. Okay, so multiple fractions for this one would be fine. If we did the original problem, I would have had multiple. I would have had one fraction. Okay, and I also would have divided by this whole mess inside and had to flip things over and deal with the exponents and all that other stuff. So it ends up being a lot messier than once that's there.
Did you do like a function,
What do you mean?
like separate them into 3 different functions?
Yeah, that's in essence what you would have had to do. Yeah. You would have had to do that if you didn't do what I just did. Because you would have had to find the derivative of this here, which would be messy. Because I would have had to do the quotient rule because I have division. I also would have had to do the product rule for the bottom. I also would have had to do the chain rule for the top and the chain rule for the bottom. So this is a very messy derivative to do. But by using the ln, I don't have to worry about that.
Did we learn the log rule, like the breakdown rule? for the next-
I would. It's going to help you. And that's the thing, like, that's where I was saying that a lot of your calculus problems are going to come down to your algebra skills, because knowing how to manipulate a problem is going to make your life easier when you're doing these problems. Okay? And that all comes down to your algebra skills. And that's the same thing my Calc 2 class is finding out. Being able to manipulate the problem is going to help you solve the problem more easily. All right. Who wants to tell me how to find the derivative of this? You're already, nope, not doing it. Nope. Huh? So we're going to have to use the quotient rule.
If you split it up,
What do you mean split it up?
like what we just did.
But I don't have an ln.
We can still like, we can do some stuff, we can turn that square root to like parentheses.
Yeah, we can change it to 1/2. That's not going to really help me. All right. So one of the options on the table is to literally go through and do all the horrible math that none of you want to do.
Split it up into like 3 different equations.
So that's the second option on the table. However, I don't have an ln. How do I put an ln in? I can't put it on the top and the bottom because I'm not multiplying by it. If I multiply a fraction, I can do multiply by the top and the bottom. That would work. I can't take the ln of the top and the bottom, though, and make it work. However, I can do something with the ln. I could take the ln of both sides. So I can take the ln of this side and the ln of this side. Actually, I'm going to write that as. Now I have an ln. Now I can split things up. No. But I can do, that's this, now you're going to do exactly what I just did in the last page. You're going to break it up. Remember, multiplication becomes addition, division becomes subtraction, exponents go down in front. You're going to do exactly what we just did to the last problem for this, for the right side. So break up that ln. I want one line with no fractions and no exponents. Nope. Well, you can have the x squared, the outside exponents. I can move out. Always a reason for things I show you before I do a massive calculus. I really should have done this problem out the correct way, like it show you actually how long it would take you to do it. Yeah, just like I did last. Yeah.
We did the last one.
You're gonna separate it up just like I did the last one. That's why I did the last one. Oh no, don't solve. Don't solve. Look at the notes. Look at the last part. You're not done with the problem. You're done. You think you're done. You're not finished. You're never done. You forgot the last one.
Professor. Definitely set federal steps so far. So,
Okay, we can't bring down the 3/4 until we split this up
would still be X.
to the 3/4. Yeah, you have to split up the multiplication before you can bring down your x1. This part's fine because you already split that part out, but you have to split those two up into addition first, and then you can bring down your x1.
Thank you, Professor.
With multiplication turned into addition.
Yeah. You don't have to that like that. There's no multiplication. But yeah, that's fine. Because I can't split up the division. You can split up multiplication, division, not addition. Yeah, that's actually right.
I just read it. Oh, okay.
That's right. Put that in parentheses. Just because then you have a plus after, it's like, okay, is that part of this or not? So you want to make this. It's for you to know too, because depending on how many more steps you do, and then you realize, then you forget like where that two actually was from. Then you have to go over here. If there's multiple things inside your LN or square roots or something like that, you want to put in practice. So this way you
Should I
go.
put
But,
this?
no, that's fine. Because the one has to go to the front. So you don't need to do you brought down your 3/4 line. You worked on your X1.
Right, if you went over it.
Your X1 was part of the LN. But you can't bring down this one and this one until after you sort that. Oh, that's.
I wanna say I got it. Again.
So that's
Wait, you don't want to root for Brad?
no rack.
Oh, yeah, that's what you just said.
You're closer than anybody else at this point.
I'm not. I
Stop
know.
No, you got the derivative of that right. You're just not done.
Oh, yeah.
You're not done, buddy.
Yeah, you
But
go.
you're fine.
Keep working on
Like,
it.
that's one of those things that I was like, I didn't expect anybody to actually do that.
Yeah.
You're right, actually, no, that's totally right. All right, so let's look at it.
Yeah, that's what I was-
So I can show the last step that nobody's got at that
It's sort of
point.
making sense, but
Okay. So I'm just gonna look at this side for right now. Okay, so we're just gonna look at that side for right now. We're gonna split up that ln as much as I possibly can. So step one, let's get rid of my multiplication change or my division and my multiplication. So I'm gonna have ln of x to the 3/4 plus ln of x2 plus 1 to the 1/2, because that's splitting up that addition, minus ln of 3x plus 2 to the 5th, because that's the division. So that's subtracted. You never deal with your exponents until after you've done that step. Okay, I did see some people do their exponents prior to that. You're going to mess it up. You could do this in 2 steps. You could have done the subtraction part first and then did the addition part on the top. That's fine. You can do it together. You can do it separately. It's not either way. It's fine. So now this becomes 3/4 ln of x plus 1/2 ln of x squared plus 1 minus 5 ln of 3x plus 2. And that's as far as you can go with the ln's. Okay. We have not found the derivative of it yet. We split it apart. Now we're going to find our derivative. What's up? You want me to look at something? Oh. Now we're going to find our derivative. So let's do the derivative of each ln. What's the derivative of ln of y? Wrong one. ln of y is 1 over y. Times y prime. Don't forget the y prime or the dy dx. Because it's a y, we need to have that. Equals 3/4 times 1 over x. One half times, what's the derivative of x squared plus 1? 2x over x squared plus 1. Minus 5 times derivative of 3x plus 2. 3 over 3x plus 2. Nope. I got to clean it up and do one last step, which I haven't shown anybody, so I wasn't expecting anybody to actually get this step right. Most people that actually got this step correct forgot that. So, which is fine because I hadn't shown you that. So, all right. So this 1 over y, I want y prime by itself, right? How would I get rid of 1 over y? I would divide it by 1 over y, which is in essence the same thing as doing what? Multiplying by y. So I can multiply both sides by y. So this side becomes y prime. Then I have y times 3 over 4x plus x over x squared plus 1 minus 15 over 3x plus 2. Can I have y and x left over in my problem? No. What's y equal? The original problem. But we don't have to do anything with it.
Pull that y out of there, take 5.
No, we're going to change y to what my original problem was, which was x to the 3/4 times square root of x squared plus 1 over 3x plus 2 to the 5th power times 3 over 4x plus x over x squared plus 1 minus 15 over 3x plus 2. And that's my answer.
Are you gonna make us ever, make that one?
No,
What is that even?
it's just the derivative. It's so then you'd have to put it together, which we're not going to do. What's the derivative? It's the slope. Right, it's the slope. So this right here, the original problem, so this was my original problem, so I don't scroll. That was a very complicated function to begin with, right? So my slope is going to be equally as complicated. That's just the slope of that original problem. That's why I said, if you go through and do the quotient rule and everything else on this, you're going to get a very similar answer. It's going to be messy. I don't feel like typing it in. It's going to take me too long. Well, we got away from straight lines. It's this the m. We did it. You just did it in this one. What's the derivative of 3x plus 2? You did it in this problem. Exactly. 3x plus 2 is a straight line. That's really what separates calculus from your algebras. So your algebras are very simple and straightforward. Your calculus allows you to do the same concepts to any function. Because unfortunately, life isn't always a straight line. So things become complicated, and we need to be able to solve those things. All right. I was doing when we get to chapter 4, we're going to start seeing a lot more of the applications. But when my Calc 2 class was doing something similar yesterday, and we were talking about how to find blood flow through a vein. So we were talking about how to find consumer surplus in economic type situations, figuring out how much waste there was. We were looking at population growth and how big of a population there was of an animal creature there. We were looking at the normal bell curve. If any of you take statistics, remember the bell curve? We were looking at being able to figure out the exact value of the probability or the percent underneath that curve. So calculus allows us to move beyond the basics into being able to do it for everything. And yes, being able to do it for everything can get extremely messy. Because as I said, life's not a straight line. Life is messy. Like, it's messy. But I don't think, except for this problem being long, I don't think there's any steps in this problem that you can't do. Okay? Like, I honestly believe everybody in here can do these steps. So, yes, it's long. Yes, it's annoying. Yes, there's a lot of little places to make a mistake, but you can do it. Okay? And that's important to understand and know. Don't look at the final answer and go, oh my God, that's messy. It's like, yeah, it is, but you got it. Or you're going to be able to get it the next time I give you a problem. All right. There is one thing that I do want to put up before we continue.
This next step is going to be long.
The chapter 3 test is probably the hardest. Yeah. Just because it's the ones with all the rules. Like chapter 4's test, we're going to be applying all the rules. But you're really not going to be learning a ton of new ones. We're just going to be using derivatives to do things. So this one's tough just because there's a ton of rules to remember. So, and actually this is a good look at those. So we have 4 different situations of things that look very similar to themselves. All right. If I had 2 to the 4th power, that's a constant, correct? 2 to the 4th power is the same thing as saying 16. What's the derivative of a constant? 0. So the derivative of any constant to the if the base is constant and the exponent is constant, it's 0 because it's a constant. All right. If the base is a variable, so if I had x squared or x to the 3rd, that's where I'm using that product rule or the power rule, where I subtract 1 and bring it down. Okay. So this is like 10, 2 to the 3rd power. This is like x to the 3rd power. This one is 3 to the x power. Okay. And this one would be, I guess it's like x to the x power. In that situation, we have to do what we just did. We have to use logarithmics to bring down that x in front. So all 4 of those look very similar. They're all dealing with something raised to a power. It's just a matter of how those things interact. Depends on the rules we want to use. And that's why I said this test is a little harder, because there's lots of little rules to remember. And there's a lot of algebra to remember to how to simplify things down, break things apart, and stuff like that. So, but I should have the test up there on Friday on my website, so you can download it, look at it. And the Tuesday after vacation, we will go over that test. So you'll have the test on the Thursday afterwards. So we'll still do the review. You'll still have the review. You still have the homework that you can review there too. I've got the quotient or the extra practice in there for the chain rule. So there's tons of practice that you can do and work on. If you want other practice, you want other problems, just send me an email. I can send you stuff. And I can even send you all the answers so you can look at them and how to do them. Yes.
Can you expand on what you mean by you're putting up the test?
I'm putting up the review test on Friday. So this way you can practice on it. That's what I'm going to do on Friday. I just haven't had it. I haven't had a chance to finish it yet. Yeah. So I just haven't. I thought I had one and I ended up not. So that's why. All right. One note card. It's all you'll need. Yeah, 10 feet by 3 feet.
What would you honestly do?
I would ask you to show me the box that you got in it that said index cards. So I will tell you, in all honesty, I've done this class many times. A 4x6 or a 3x5 index card is honestly all you'll need. Okay? If you truly need more than that, you really don't understand it that well. Okay? Take the review test, do the review test, write your index card based on that review test. You'll have plenty of space to put it down. Okay? It's like, I know everybody freaks out about it. It's designed to get you to study and put down the stuff that you truly need to remember how to do, and not everything, because you don't need everything. Okay? All right, let's look at this one. So what's the derivative of sine of x? Okay, We figured out what's the derivative of tangent of x. We've done that one. We had the answer. You do not need to have memorized that one. The sine and cosine ones you should have known. What's this? It's the inverse sine or arc sine, right? So these are the opposites of them. So I want to figure out what the derivative of this is. So we don't have a derivative of this. However, this is the same thing as saying that, correct? Okay. All right, so let's find the derivative of that. What's the derivative of sine of y?
Y prime.
Okay. You could do it either way. But I would say put it in front, not at the end. So you don't confuse it with being inside the cosine. What's the derivative of x?
1.
Okay. Then we've got to bring it over. So dy dx is 1 over cosine of y. But I don't know what. Do I?
Why is this bigger side?
So what's the cosine of the inverse sine of x? That's going to be really complicated to figure out, right? So, all right. So let's use the other things that I have. Okay. So I've got sine of y equals x, correct? Sine squared of y equals x. X squared, right? I just squared both sides. Okay. I don't want to screw that up. Can I do that? As long as you do the same thing to both sides, same thing, right? Okay. What's that equal? Cosine squared. So remember, this is where, again, remembering some rules helps. So I have sine squared x plus cosine squared. I'll use y just so I don't screw you up. That's Pythagorean identity, correct? If I move the sine over to this side, I would have that. So this is cosine squared y equals now 1 minus x squared. I don't want cosine x squared y, right? I want cosine of y. Take the square root of both sides. So that cosine of y is 1 over the square root of 1 minus x squared. And that's the derivative of the arc sine of x. Remember what I said? You're not going to have to remember everything. These are some of those rules. Like this is not a rule that you're going to memorize. This is a rule that if you're going to need, you're going to look up. Okay. So on the test, if you see something that's asking that has the arc sine in it, you're probably going to need to know this rule. This is one of those ones you put down on your index card. Okay, I'm going to need this rule, put this one on my index card because I'm not going to remember it. All right. You are not, if I don't put cosine, the arc cosine on there, you're not going to need the arc cosine on your actual test. So you don't need to write down every arc trig rules. You're only going to have to write down the ones that I've used on the actual test. Okay. That's where I've said how you start to limit the things that you're going to need to actually write down. Because I don't memorize that. I look it up. All right. I don't have every single derivative rule memorized. I have the textbook sitting in front of me when I'm teaching up here. If I need to look something up, I look something up while you're looking at the board. Okay. We all do it. You're never going to have to memorize a bunch of stuff when you leave here. You can look things up. That's what the internet and Google is great for. All right. Same concept on your test. You're going to use the index card as your Google at that point. Write down the things that you specifically need for that test. Okay. Yes. No. So that is the derivative of that. So I just rewrote what there was underneath it. I'm going to actually write it a little bit better in a second.
The method of doing this is work the original problem as much as you can. When you get stuck, go back to the original and find whatever you're looking.
Yeah, look for other rules to possibly help break things down. So and that's really the thing. It's like you got. I know you don't because you don't remember a lot of the stuff, but you have learned a ton of rules and things to be able to manipulate stuff. So here's all the derivatives of the trig functions. They'd all be done the exact same way that we just did the sine one, so that I am not going through and doing them all. Okay? You're not going to have to write all those on your next card. I'm probably going to have one of them on the test. And it'll be the same rule as the one that's on your report on the practice test. So if I use secant, arc secant, you're going to need this one on the actual test because that's the one I used on the review test. You will not need the other 5. Okay? That's how I help you actually create your index card with the review test. So, but know that there are derivatives for all those arc trig functions or the inverse trig functions. So if those come up, you know where to look for that information. Okay. So we can find the derivatives of all those because as we saw in the last problem that we did, things can get messy and you can get crazy things like that. What you don't want to do is you don't want to put an inverse trig function inside of another function because that makes it a lot messier. So yes, I could have put in sine of x, the arc sine of x inside of my cosine, but then I would have had to do a lot more work to find my answer anyway, and I wanted as simplified as possible at the end. And these things make it as simplified as possible. Okay. All right. Let's do one of these. So we'll do 2 more problems. All right, try this one. Write the problem down. I will switch back over to the other slide so you can see the derivative rules. So you don't have to actually flipping back and forth because I know you didn't all write them down. Everybody got this problem written down? All right. We good? All right, there's your rules. So x squared minus 1. All right. What's the derivative?
Square root is the square root of x to the fourth.
There's a reason I wrote 2 squared. Remember, you're replacing that where the x's are. Okay. So that inside doesn't say 2x squared. It's x squared squared. That's where the x to the fourth comes in. I can cancel out one of the x's on the top and the bottom because I have that there. So it'll end up being 2 over x squared of x to the fourth minus 1 is your final answer.
Two X. You're just putting the two in front of the X.
Well, what's the derivative of x squared?
2.
Right. That's where the 2x came from.
Oh, so you separate.
Well, you still have to do that. That's it, you're doing the chain rule.
Yeah.
You're doing the chain rule. So you're taking the derivative of the inside, which is 2x, times the derivative of the rest of the problem. Yes. So remember, you're basically replacing that x and that x with that x. So that x becomes x squared. That x becomes x squared, but it was already squared. So that's why it's squared again. So that's why I wrote it specifically that way, because I didn't want people to think like where the like why was it x to the fourth? It's like it's because it's squared. So those two were coming from that. Okay. All right, 2 easy ones or 1 hard one.
Well, how long? Is it like the one-
You've seen the problems I've given you today, right? Like you've seen the questions I've given you today, right?
How much harder can I get?
We're gonna do 2 easy ones.
So.
Yeah. Who was it we did it with?
I already planned the 2 easy ones. I was giving you the hard one anyway. No, this is an easy one.
I thought you said you're giving us.
No. Yes. Normally, I do expect people to pick the hard one, but it's like I'm not giving it a hard one.
Expect people to choose the hard one.
Well, yeah, because 1's easier than 2 normally. It's the whole concept of if you see 2 stores next to each other, and one says 50% off and one says buy one get one free, you're going to the store that says buy one get one free every single time, even though they're the exact same price, and you might not need 2. Buy one get one free, or 50% off is the same price. All right, try these 2. The first one you do need to use the product rule on, so because we do have a product. Yeah, you did do your project. Do not need to use the picture. You don't need to use the picture, either one.
That's it.
Yeah.
Oh.
That's the beginning of the product roll. Actually, wait. No, you did the, okay. No, you didn't do the project roll, so that's what you did this, remember, it's the derivative of the first times the second, plus the derivative of the second times the first. There's an addition of the product. You found the derivative of both pieces. But you didn't do the product. You said that.
Oh. The product roll is all 19. Okay, we never.
Both of these will have addition in your final answer. Now she totally crosses off everything she wrote. Yes. Up to the second. That is it. All the little things in it that will. Well, they have. Sometimes easy ones. Product roll. Product derivative of these things. That's right.
Thank you. 2x ln x plus x. Plus on x is over x. Yeah. So we got the same thing. I thought they were going to be a lot harder. I was thinking, wait, are they really that easy? Yeah.
I don't know.
What?
I know how to change it. Like, I feel like I'm getting the right answers and I'm just kind of like, sure,
Yeah. why not?
sure, okay.
The chain rules.
It's the magic of math. It's just poof, there. I'm gonna do the second one first, just because that one's really simple. That's it. This one, you need to use the product rule. Remember, it's f prime of x times g of x plus g prime of x times f of x. So y prime is 2x ln of x plus 1 over x times x squared. So 2x ln of x plus x. You cannot put those two together because of the ln of x. Okay. All right. If you asked for if you got the hard one, that would have been the hard one.
Oh. Yeah, I like the
So,
I don't want to try that one.
I have to have it back and write it down.
all right, so I'll flip it back over in a second. No, not that you're gonna have to do. Anybody who wants to write it down, actually try it, they can. All right, so your test is the week after spring break. The review is gonna be on Monday, the test will be on Wednesday. I believe it doesn't really matter. Your midterm grades are already in Blackboard because it's what you have right now. As soon as I put the other test in, those will change, but it's not an official grade anyway. It's just to give you a progress on where you are. So once you take that test, I'll have it graded that weekend and I'll put those up there so you can see where you are at that point. So, any questions? If not, have a good spring break. I know 99% of you are going to be working and not going away to like Acapulco or Florida, but you know, at least it's a week off of school. You are? Yes. Like that's normally for like the regular colleges. Community college, everybody works. So it's like, I'm just gonna go work.
Hey, Professor,
Yes.
did we stay to try that other problem?
Yeah, if you wanna.
All right.
honestly, are making sure that other and all 4 days have everything set. They're like, so like, all right. She's like, we're all in a group on this. She's like, she's like, my mom's handling this. She's like, reserved all the parts. We're doing this.
Oh, yeah.
Time limit. I'm like,
You wanna study after class on Monday?